Okay, so to start off, I want you guys to practice with your partners, and I want you to graph A and B. I want you to graph both of those on this graph, okay? So just as a quick review, I want you to graph both of those lines on that one graph. So you're going to have to solve the first one for Y, graph A. Then solve the second one's already solved for you, so just go ahead and graph B, okay? All right, go ahead with your partners. Okay, so on A, I'm trying to get Y all by itself, so I need to get rid of the 6x term. So I do the opposite and subtract 6x from both sides. So I have negative 3y equals, are 15 and 6x like terms? No, so they just get they are written side by side, 15 minus 6x. And then I divide by negative 3 on every piece. And last but not least, I have y equals that's positive. 15 divided by negative 3 is negative 5. Negative 6 divided by negative 3 is a positive 2x. So now I have a slope and a y-intercept. My y-intercept is negative 5. So that's where I begin, down 1, 2, 3, 4, 5 on the y-axis. And a slope of 2 tells me to go up 2 over 1, up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. And then I go ahead and make my first line. Remember, this should hopefully be a little bit easier than last week because I don't care about dotted or solid. I don't care about shading. I don't care about any of that stuff. Okay, so there's my first line. I'll do the second line in blue. So I have y equals x minus 2, so I have a y-intercept of negative 2. And a slope of what? 1, right? 1 over 1. So y-intercept of negative 2 is down 2 on the y-axis. Slope of 1 is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. You have just done your first systems of equations. Okay? So you just graphed, you just solved your first system of equations. The only other thing we need to talk about is what the solution is, okay? So, when it says two or more linear equations together form a system of linear equations, just like last week when we had two inequalities formed a system of linear inequalities. Let me ask you, okay, what was the answer to the system of the linear inequalities? So if I come over to the side here and I graph a system of linear inequalities. Okay, so I have the first line maybe was like this, and it was shade below. And then the second line, maybe it was dotted like this, and it was also shade below. How did I know what the answer was? Yeah, Michael? Where the two shades overlap or meet, right? So the answer to the system of inequalities was where both shadings happened, right? So this area right here satisfied both this inequality and this inequality, right? Inequalities have lots of answers. So the overlapped shaded region was the answer to the system of inequalities because it was the answer to both of the inequalities in the system. So if I take that concept and I try to apply it to a system of equations instead of inequalities, I am looking for the answer that satisfies both lines. So what answer satisfies both lines in this system of inequalities? Or system of equations, excuse me. It would be 1 over 3. I want the ordered pair. All of the blue points are the answers to the blue line. All of the red points are the answers to the red line. So what point is on both lines? What point is on both lines? 3, 1, right? This point right here. 3, 1. That's the point of intersection. And that's what we're looking for. It's the point 3, 1. So filling in our little blanks here says an ordered pair that makes both the equations true is a solution of the system. So the answer up on this first one is the ordered pair that makes them both true, which is over 3 up 1, so 3 comma 1. Okay? All right, so let's look at a couple examples here together. So let's look at example 1. Okay? So I want to graph both of these equations on the same graph, and I want to find out where they intersect. Okay? So this first line, I'll do it in red. So y equals 2x minus 1. So I need my m, which is 2 over 1, and I need my b, which is a negative 1. So I'm down 1 on the y-axis. Slope is up 2 over 1, up 2 over 1, up 2 over 1. Can also go down 1 and left 1, down 1, or down 2 and left 1. So I put as many points on the graph as I can because hopefully one of those points will be the point of intersection. I go ahead and make my red line. So there's my first line. Okay, and then my second line, I'll go ahead and graph in blue. So on this line I have an m of negative 3, and remember I can put it over 1, and a y-intercept of negative 1, so b is negative 1. So I go ahead and graph my y-intercept of negative 1. It looks like that's where the point of intersection is going to be. And then a slope of negative 3 tells me to go down 1, 2, 3 over 1. I can also go up 1, 2, 3 and left 1. Up 1, 2, 3 and left 1. And I go ahead and make my line. So remember, the solution to a system of equations is the point that makes both equations true. And when I graph them, that means I'm looking for the point of intersection. So these intersect right here. And what's that ordered pair? Over how many? Over 0, down 1. So that's a negative 1. So 0, negative 1 would be my answer. So in the blank that says answer, I would write in 0, negative 1. Okay, let's try one more together. Okay, any questions on one so far? Can I get a comfort level on how you guys are feeling right now? Have we ever done that in this class? Not really? Okay, a comfort level means basically, just kidding. Okay, so here we go. All right, so number 2, let's go ahead and do one more together here. Okay, so I have y equals 5 halves x plus 1. So identify my y, or excuse me, my m and my b. So let's identify m is what? 5 over 2, that's my slope, the number next to x. B is a number all by itself, that's 1. So now I graph, so up 1 on the y-axis. 5 halves tells me to go up 1, 2, 3, 4, 5. I'm going to go off the graph a little bit, that's okay. And over 2, I can also go down 1, 2, 3, 4, 5, and left 2 to go the opposite direction. Okay, so I can go ahead and graph this line. And now let's go ahead and graph the second line. So the second line I'll do in red here. So I have an m of 1 over 1, right? That's the number, the imaginary number in front of x. And then my b is my y-intercept, that's negative 2. So I start down 2 on the y-axis. And I'm going up 1 over 1, up 1 over 1. Looks like I'm getting farther away from the line. So let's go the opposite direction. Let's go down 1 and left 1. Down 1 and left 1. Looks like that's the point of my intersection, down 1 and left 1. So there's my line. And then my point of intersection, the point that makes both of them true, is left 1, 2. Down 1, 2, 3, 4. So negative 2, negative 4 would be my point of intersection. Okay? All right, go ahead and do the 3 try these with your partners. I'm going to be filtering around the class. Make sure you realize on number 3 you have to do a little bit of solving, okay? So go ahead with the 3 try these problems. Okay, so number 1, I have a slope of negative 1/2 and a b of 2. So up 2 on the y-axis. And I'm down 1 over 2, down 1 over 2, down 1 over 2. Can also go up 1 and left 2, up 1 and left 2, up 1 and left 2. So I have as many points on there as I can. There's my first line. Second line, I have a m of -3 over 1 and a b of -3. So I'm down 1, 2, 3 on the y-axis. And then a slope of -3 will take me off the graph. So I want you guys to realize something. -3 over 1 is the same as if I do 3 over -1, if I just put the negative on the other piece. So if I'm putting the negative on the other piece, it's now telling me to rise up 3 and run which way? Left, right? Left is a negative run. So I would rise up 1, 2, 3 and left 1. I would rise up 1, 2, 3 and left 1, and it looks like that's where they're going to cross. So they cross right there at left 1, 2, up 1, 2, 3. So -2, 3 would be my point of intersection. Okay? So -2 would be my answer for number 1. Okay, let's look at number 2. Okay, so I have on the first line, x equals 5. So everybody show me the x-axis with your arm, please. X-axis. X-axis. Good, and then x equals. Opposite of that. So it's a vertical line over 1, 2, 3, 4, 5 at x. So there's my x equals line. X equals 5. Then my red line, I have an m of 1/5 and a b of -3. So down 1, 2, 3 on my y-axis. And a slope of 1/5 is up 1 over 1, 2, 3, 4, 5. And that's where they're going to cross right there. So this point right here is over 1, 2, 3, 4, 5, down 1, 2. So 5, -2 would be my point of intersection. Any questions so far? Okay, and last but not least, number 3, you have a little bit of solving to do. Okay, I got to get y by itself. So top equation, I have to divide by a -3 on every piece. And then that one's in slope intercept, so I have y equals, looks like -2/3 x, -6 divided by -3 is a +2. So then my b is 2, my m is -2/3. So let's graph that. So b of 2 is up 2 on the y-axis. M of -2/3 is down 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. Can also go up 2 and left 3 to go the opposite direction. Go ahead and graph that line. Second line I'll do in blue, so I need y by itself again. So I subtract x from both sides. I have 4y equals 8 minus x because those aren't like terms. So they just go side by side. I divide by 4 on every piece. Oops. And I end up with y equals 8 divided by 4 is 2. And then I have a -1 over 4x. So then my m is the number next to x, that's a -1/4. B is a number all by itself, that's 2. So up 2, it looks like they're going to cross on the y-axis there. Slope of -1/4 is down 1 over 1, 2, 3, 4. Can also go up 1 and left 1, 2, 3, 4. Like I said, they cross right here on the y-axis. That's over none up 2. So 0, 2 would be my answer there. So that's all it is. You're graphing two lines on the same graph, trying to find out where they intersect, because that point of intersection is then the answer to your system. Okay? All right.